this is Anita, your chemistry mentor, welcoming you for one more session in amines. Today we shall see all the important naming reactions under amines from which you can definitely expect questions in board and other exams. Okay, let us start our session, students. First one is carbylamine reaction. Okay, see this reaction is otherwise called as isocyanate test. Okay, see in this reaction when an aliphatic or aromatic primary amine is heated with chloroform and alcoholic KOH, an isocyanate, it's otherwise called as carbylamine, having an offensive smell is obtained. What do you mean by offensive smell? It's an unpleasant smell is obtained. This reaction is known as Carbylamine reaction. Okay, so both aliphatic and aromatic primary amines can be used here, and it is heated with chloroform, right? So at first I have taken the aliphatic primary amine. This is ethylamine. Okay, so ethylamine I have taken ethylamine. So this is treated with chloroform CHCl3. This is nothing but chloroform. Okay, chloroform and alcoholic potash. When it is heated, this ethylamine will be getting converted to ethyl isocyanide. Okay, so let me write CH3 CH2. So this is ethyl and isocyanide. Isocyanide means N triple bond C. Okay, this is isocyanide. So rest will be getting KCl, potassium chloride. It is this 3 potassiums, okay, K combined to 3 Cl and it forms 3 KCl, okay. And then what else is remaining? Hydrogen, right? Here 3 hydrogens. Here we are having 3 hydrogens, and here also we are having 1 hydrogen, and here we are having 2 more hydrogens. All these hydrogens combine with this oxygen and it forms 3 molecules of water. Okay, so this is the product we are obtaining, and the name of this compound is ethyl carbylamine. Okay, we can have this name as ethyl carbylamine, and it's otherwise called as ethyl isocyanate. Okay, this is otherwise called as ethyl isocyanate. Okay, now I have taken another amine, then it is a aromatic primary amine. Okay, and the aromatic primary amine, the name of this compound you all know, this is aniline, right? Aniline. When this aniline is treated with chloroform and alcoholic potash, and when this mixture is heated, we'll get phenyl carbylamine. We'll get phenyl carbylamine. Just the same reaction takes place. Okay, what we saw in the previous one. So O, okay, here N triple bond, okay, triple bond C. Phenyl isocyanate or phenyl carbylamine plus 3 KCl, okay, 3 KCl plus 3 H2. Understood? So what's the name of this compound? Phenyl carbylamine. Okay, phenyl carbylamine. Okay, phenyl carbylamine. Understood, students? So this is the actually this reaction is answered only by the primary amines. Okay, only the primary amines will be undergoing this reaction, and therefore this reaction is used as a test for primary amines to distinguish between primary amines from secondary and tertiary amines. Understood? So this is a perfect test for the primary amines because primary amines alone will be answering this. Understood, students? Let us see the next naming reaction. It is Libermann's nitroso reaction. Okay, Libermann's nitroso reaction. See, we are having different steps here. Okay, let us see one by one. The first step is both aliphatic and aromatic secondary amines react with nitrous acid to form yellow colored oily N-nitroso amine. Understood? See here, only the secondary amines will be reacting. Understood? So the previous one, primary amines, here it is secondary amines. But both aliphatic and aromatic compounds will be undergoing this Libermann's nitroso reaction. Okay. So first this secondary amines will be treated with nitrous acid. When it is treated with nitrous acid, it gives yellow colored oily nitrosamine. So I hope we can see step by step. So I have taken a secondary amine. So the name of this compound is diethylamine. Okay, this is diethylamine. Diethylamine. See here, see we are having 2 ethyl groups, right? So diethylamine. When this diethylamine is treated with nitrous acid, HNO2 is nothing but it is nitrous acid, we get a compound, and it is a yellow colored compound. Let me write the compound now, C2H5N, Again here C2H5. Okay, so what happens is, see this oxygen, this combines with hydrogen and this hydrogen and it forms water molecule. Okay, and it forms water molecule. So the rest of the compound here we have to join. So N double bond O plus water. Okay, understood. So the name of this compound is N nitroso diethylamine. Diethylamine. Okay. Now this is the first step. So what happens in the second step? This yellow oil, see this has an yellow color and it is an oily substance. This yellow oil nitrosamine, when heated with phenol and few drops of concentrated sulfuric acid, gives a green colored solution. Okay. So either phenol we can use or ethanol, right? When this is treated with ethanol, right? We can write ethanol or phenol, okay? C2H5OH when it is heated, and this gives, in the presence of sulfuric acid H2SO4, it gives a green colored solution. Okay, green colored solution. Now, when this green color, this is the next step, when this green solution is made alkaline with NaOH, the color of the solution changes to deep blue. Understood? See, when this green colored solution is treated with sodium hydroxide, okay, NaOH, and if it is made as an alkaline solution, it will be getting converted to a deep blue colored solution. Understood? And when again this deep blue colored solution, when this on dilution, this blue colored solution on dilution will be getting changed to red color. Okay, this blue solution will be getting converted to a red colored solution. Understood, students? So this is Libermann's Nitroso test, and this test will be answered only by the secondary amines, aliphatic as well. Okay, next we shall see the next reaction, Shorten-Bauman reaction. See, it's a very important question. Okay, Shorten-Bauman reaction. See, both aliphatic and aromatic amines can be benzoylated with the help of benzoyl chloride in the presence of a base pyridine or dilute sodium hydroxide. Understood? This reaction is called a Shorten-Bauman reaction. Both aliphatic and aromatic amines will be undergoing Shorten-Bauman reaction, and this can be benzoylated. What do you mean by benzylation? Actually, it is the introduction of a benzoyl group. What is benzoyl group? Let's say, let me write the give the benzoyl group C6H5C double bond O single. Okay, so this group is called as a benzoyl group. When this benzoyl group is introduced in a molecule, then that process is called as benzylation. Okay, so this what happens now? We have taken the compound benzoyl chloride and we have taken the aliphatic primary amine now. Ethylamine is aliphatic primary amine. Okay. So in the presence of either aqueous sodium hydroxide or pyridine, this reaction takes place. So what happens is, see, there will be a removal of HCl. This hydrogen from this NH to one hydrogen, and this chlorine will be combining and HCl will be removed. Okay. And then you should write the rest of the product. Let me write now. C double bond O. Now there won't be any Cl because this Cl will be taken up by this hydrogen. Okay. So the rest we should write. How will you write? NHC2H5 plus HCl. Understood, students? See, hydrogen from here will be combining with chlorine, and then you should write the remaining. Okay, you should add up. And this compound is, the name of this compound is N-ethyl benzamide. Okay, benzinamide. Okay, benzinamide. N-ethyl benzinamide. So this is the name of the compound. So what happens when an aromatic amine is treated with benzoyl chloride? This is aromatic amine, is it not? This is aniline, right? This is aniline. And when aniline is treated with this benzoyl chloride, okay, this is benzoyl chloride, aniline is in the presence of aqueous sodium hydroxide or pyridine. Either pyridine we should use or aqueous sodium hydroxide. The same reaction takes place. What happens? One hydrogen from here combines with this chlorine and This will be removed as HCl. Okay. So you should write the rest of the product. So this is easy. This is the easiest reaction, short and permanent reaction, but it's a very important reaction. Okay. Double bond O, and here you have NH, and then we'll be having this benzene. Okay. Plus HCl. HCl will be removed. So what's the name of this compound? Benzene. Benz. B E N S Z A L I D E. Benzanilide. Benzanilide, or how will you write? N, or another name is also there. N phenyl. N phenyl benzenamide. Benzene amide. Benzenamide. Understood? Because this phenyl group is attached to the N, nitrogen. So N phenyl. This is nothing but benzenamide. Okay, benzenamide. Understood? So next important reaction is diasotization. Okay. See, the process of converting a primary aromatic amine into a diazonium salt by treating with a cold solution of nitrous acid is called as diasotization. Understood? So it's the process of converting primary aromatic amine, okay, into a diazonium salt by treating with nitrous acid. See, first let us prepare nitrous acid, freshly prepared nitrous acid we need. So for that, sodium nitrate we have taken plus HCl. When you are treating sodium nitrate with HCl, you will be getting NaCl plus nitrous acid. Okay, HNO2. So this is nothing but nitrous acid. Okay, nitrous acid. Right. Now this nitrous acid will be reacting with aniline. So this is aniline is a primary aromatic amine. Okay. So now when it is treated with nitrous acid in the presence of HCl at 273, between 273 to 278 Kelvin, there will be a removal of water molecule. There will be a removal of water molecule, and we will be getting the final product. Okay. So the product will be like this. N triple bond N Cl. Okay, here we'll be having the plus simple and simple. Understood? So this is nothing but benzene diazonium chloride. Benzene diazonium chloride. Understood, students? Benzene diazonium chloride. So this is how the reaction takes place. So the next important reaction is coupling reaction. What do you mean by coupling reaction? So actually the aromatic amines react with diazonium salts. Okay, diazonium salt means benzene diazonium chloride is an example. So aromatic amines react with diazonium salts at low temperature to form a brilliant colored azo compounds called azo dyes. This reaction is called as coupling reaction. Okay, so normally the aromatic amines, so this is aniline. So I have splitted this NH2. Okay, phenyl ring and NH2 I have written like this. NH2 I have written like this. So aromatic amines reacts with the diazonium salts. Okay, benzene diazonium chloride. At low temperature we will be getting an azo compound, and it will be having brilliant color, a bright color, and those compounds are otherwise called as azotide. So this reaction is called as a coupling reaction. So what happens during coupling reaction? So this reaction takes place at 273 Kelvin. 273 to, okay, wait, 273 to 278 Kelvin. Okay, and the pH should be maintained between 4 to 5. Okay, pH should be maintained between 4 to 5. So in this reaction there will be a removal of HCl. Okay, there will be a removal of HCl. Understood, students? So there will be a removal of HCl minus HCl. So just write the rest of the compounds now. N, right? Double bond N. Again there will be one N, then H, then a phenyl ring. Okay, there will be a phenyl ring. Understood? So the name of this compound is diazoamino benzene. Diazoamino-benzene, and this is an yellow dye. Understood? And this is a yellow dye. Understood? See, if you're again when you're heating this to 303 to 313 Kelvin, this compound undergoes a rearrangement. This rearranges, okay? This undergoes rearrangement, and this what happens, we'll be getting another compound with a different structure, N, double bond N. See here, what happens is that as I told you, rearrangement takes place. This NH will be going to this position. Already there will be one hydrogen here. So this NH combines with this hydrogen and it forms NH2. Okay, so NH2. Okay, so this compound is otherwise called as para amino. See, in the para position, this is para, okay, this is in para position. So para amino group is present in the para position, okay. So para amino azo benzene. Understood, students? Para amino, and this will also be having yellow color. Understood, students? Hope you might. Next, we shall see another important reaction, Sand-Meyer's reaction. Okay. See the reaction involving the replacement of N2 and X minus. Okay, N2 plus and X minus group present in the diazonium salt by Cl and bromine group by heating with the diazonium salt with cuprous chloride or cuprous bromide with a corresponding halogen acid is called a Sand-Meyer reaction. See what's given in this sentence is, say this N2 plus and Cl minus from the diazonium. This is a diazonium salt. So the N2 plus and Cl minus will be replaced by either chlorine or bromine. If you are using a chloride salt here, will be replacing with chlorine. If you are using a bromide salt, then it will be replaced by bromine. Okay. So replacement of this group by either chlorine or bromine in the presence of the corresponding cuprous chloride or cuprous bromide and the halogen acid. This is called as Sand-Meyer reaction. Okay. So now let us write. So I am going to brominate this. Okay. In this Sand-Meyer reaction, we are going to brominate. So we have taken cuprous bromide. This is cuprous bromide and the corresponding acid we need. So HBr. We have taken HBr. Okay. We are going to replace with the halogen bromine. So we have taken the corresponding acid, that is HBr. Okay. HBr, right. So what happens here? See, this is the reaction. Br. See here, N2 Cl minus is replaced by Br. So we are having two molecules plus nitrogen will be liberated plus this cuprous, right? Cu2 Cl2. See here, this cuprous bromide is getting converted to cuprous chloride. Understood? See, this chlorine will be getting added up to this, right? So this is the product. This is how we are preparing bromobenzene. Okay, bromobenzene. This is nothing but it is a haloarine, bromobenzene. Understood, students? See, next important reaction is Gattermannn reaction. In this reaction, an aqueous solution of diazonium salt is heated with copper powder and a corresponding halogen acid. So what happens is the group in diazonium salt, the same group N2Cl minus group will be replaced by either chlorine or bromine. So if you want to substitute with bromine, then you should take HBr. If you want to substitute with Cl, then you should take HCl. Understood? So instead of in the previous one in Sand-Meyer's reaction, we have taken cuprous chloride or cuprous bromide, but here we are taking copper powder. So this is a modified Sand-Meyer reaction. Okay, this is a modified Gattermann's reaction is a modified Sand-Meyer's reaction. So instead of cuprous chloride, we have cuprous chloride or cuprous bromide. We are taking the copper powder. Okay. So what is the product now? This is the product. Okay, we will be getting a haloarine, right? Bromine. Okay, bromobenzene. Bromobenzene plus N2 plus Cl. Okay, so this is the product. This is how we'll be naming reactions. Apart from these reactions, we are having three more naming reactions in this lesson, which I have dealt in my previous video on preparation of amines. So for your convenience, I am sharing the link of the particular video in the description box for your perusal. I shall meet you with an very important topic within a short period. Until then, it's Anita Raj signing off from you. Thanks for watching.